An electron is a wave. An electron is a particle. Both statements are true. Both cannot be true. And yet, both are true. I spent my life in the space between those contradictions, and I want to tell you, the strangeness you feel when holding those thoughts together is not confusion. It is the first honest sensation of reality itself. Let me take you to Copenhagen, to those long evenings at the Institute where we wrestled with what quantum mechanics was trying to tell us. The mathematics worked beautifully, predicted experimental results with impossible precision. But what did it mean? What was actually happening when we weren't looking? Einstein, my dear friend, believed there must be something beneath the quantum description, some deeper reality we simply hadn't uncovered yet. He could not accept that God would play dice with the universe. But perhaps God does not play dice. Perhaps instead, reality itself has no single face to show us. Perhaps the dice do not exist until we roll them. Consider what happens when you observe an electron. Before measurement, it exists in what we call superposition, not in one place or another, but genuinely, physically, both. The mathematics describes a wave function spreading through space, a cloud of possibility. You might think this is merely our ignorance, that the electron is really in one spot, and we simply don't know which. But the experiments betray that comfortable thought. The electron truly acts as a wave when unobserved, passing through two slits simultaneously, interfering with itself in patterns that single particles cannot make. Then you measure it, you look. And in that moment of observation, the wave function collapses. The spread of possibility condenses to a single point. The electron appears here, not there. Did you discover where it was? Or did you create where it is? The question itself may be imprecise. And this is where we encounter the first deep limit, not a limit of technology or cleverness, but a limit woven into the fabric of what can be known. I came to believe that physics does not describe reality as it exists independent of us. Physics describes only what we can say about nature through measurement. And measurement is not passive discovery. Measurement is interaction, participation, a conversation where the asking changes what is asked. In those debates with Einstein, walking through Danish streets in twilight, he would press me. Surely the moon exists when no one looks at it. And I would respond, perhaps. But what does it mean for the moon to exist when no one looks? Every property we ascribe to it, position, momentum, spin, these are answers to questions we ask through measurement. Without measurement, without interaction, what remains is not a moon with hidden properties we simply don't know. What remains is undefined, a wave function describing possibility rather than actuality. This is not philosophical wordplay. This is what the mathematics tells us, what experiments confirm again and again. There is a limit built into reality. You cannot specify all properties of a system simultaneously because those properties do not exist simultaneously in the way classical thinking assumes. To have position well defined is to have momentum undefined. To measure one is to make the other indefinite. Not because of clumsy instruments, because nature itself refuses the question. One might ask, what is the electron doing between measurements? Where is it really? How fast is it really moving? And nature responds, not with hidden answers we lack tools to find, but with silence. The questions themselves dissolve. The electron is not doing anything between measurements in the sense the question assumes. It exists in superposition, in potential, in relationship to what might be measured but has not been. This troubled Einstein deeply. It troubled many of us. We wanted to believe that objects possess properties independent of observation, that reality hides beneath quantum descriptions waiting to be uncovered. But quantum mechanics resists this interpretation not through incompleteness, but through what it shows us. Complementary descriptions that are each necessary, each complete in their domain, yet mutually exclusive. Wave or particle, not sometimes one, sometimes the other, not one in some situations and the other elsewhere, but fundamentally both, with the context of measurement determining which face reality shows. The wave description is complete for certain questions. The particle description is complete for others. But you cannot have both answers simultaneously because reality does not offer both faces at once. I called this complementarity, and it runs deeper than physics. Consider language itself. To describe anything, we must choose a framework: position or momentum, wave or particle, subject or object. But these frameworks are human constructs, categories we impose to organize experience. Reality may not cooperate with our categories. It may require multiple incompatible frameworks to capture its richness. And the limit is not in our thinking. The limit is that reality itself is richer than any single description can hold. Perhaps you feel resistance to this. Perhaps you want to say, surely there is one true description, one complete picture we simply haven't found yet. I understand that desire. I felt it too. But the experiments speak clearly. When we force reality to answer particle questions, it behaves as a particle. When we ask wave questions, it behaves as a wave. The behavior depends on how we interrogate nature. And this dependence is not incidental. It is fundamental. The measurement problem runs deeper still. We are not separate observers peering at an independent reality. We are part of the system. Every measurement requires an interaction between observer and observed, a physical connection that entangles their quantum states. The boundary between subject and object dissolves. We cannot stand outside nature to observe it objectively because observation itself is a natural process, a quantum interaction that creates the classical outcomes we experience. This is the second deep limit. We cannot access reality before observation because observation is what transforms quantum possibility into classical actuality. There is no view from nowhere. There is no God's eye perspective outside the quantum system. We are both spectators and actors, and the separation between the two is an illusion. In those long nights at the Institute, Heisenberg and I would explore these questions until dawn. His uncertainty principle showed mathematically what I sensed philosophically, that certain pairs of properties cannot be simultaneously specified because measurement of one physically disturbs the other. But even this language is too classical. It suggests the properties exist with definite values before measurement, and we merely disturb them. The truth is stranger. The properties do not have definite values before measurement. They exist in superposition, and measurement creates the definiteness we experience. One might also ask, what triggers the collapse from superposition to definiteness? When does the wave function collapse? And here we encounter perhaps the deepest mystery. Some say consciousness collapses the wave function. I am uncertain. But I know that wherever we draw the line between quantum and classical, between possibility and actuality, we face paradox. The border shifts depending on where we place the observer, and perhaps there is no natural border. Perhaps the universe is fundamentally relational, existing in networks of interactions rather than containing objects with intrinsic properties. Einstein could not accept this. In one of our last conversations, he asked, "Do you really believe the moon is not there when nobody looks?" And I responded with what I truly believed, that when we say the moon is there, we mean it has properties, exists in states, possesses features. But all these terms derive their meaning from actual or possible measurements. A moon that could never be measured, never interact with anything, that leaves no trace in space-time. In what sense does such a moon exist? The question contains its own limit. We cannot speak meaningfully about existence independent of all possible interaction, because existence shows itself through interaction. This does not make reality subjective or imaginary. The moon is quite real, but its reality is relational rather than intrinsic. It exists in patterns of interaction, in relationships with other parts of nature. Properties emerge through measurement, not because measurement reveals hidden values, but because the interaction of measurement creates classical definiteness from quantum possibility. Perhaps this seems like word games, like evasion of the real question. But the real question may be imprecise. We ask, what is quantum reality? But this assumes a single answer stated in classical terms. Quantum reality may be fundamentally unlike the pictures we build from everyday experience. It may be that nature refuses a complete description because completeness is a classical concept that does not apply to quantum systems. The limit, then, is not speed or energy as others have explored. The limit is conceptual completeness. Reality does not provide a single, complete picture visible from all angles simultaneously. It provides complementary aspects, each complete in their context, but mutually exclusive. To see the wave face is to lose the particle face. To specify position is to lose momentum. Not because of ignorance, but because nature itself is complementary at its foundation. Language fails us here. All our words, particle, wave, position, measurement, carry classical assumptions. They suggest objects with definite properties, existing independent of observation. But quantum mechanics shows that these assumptions break down at fundamental scales. We use classical language to describe quantum phenomena because we have no other language. But we must remember the words are metaphors, pointers toward something our everyday experience cannot fully capture. And yet, perhaps language does not fail so much as reveal its own nature. Language is complementary too. To describe is to choose a framework, to adopt a perspective, to partition the world into subject and object. But the partition is not given by nature, it is created by the act of description. And different partitions are possible, each valid in its domain. In this sense, the quantum revolution was not just physical, but philosophical. It showed that the limits we encounter are not temporary obstacles to overcome with better instruments. They are features of reality itself, boundaries built into the relationship between knowing and being. We wanted physics to tell us what reality is. Instead, it tells us what we can meaningfully say about reality through interaction. And perhaps that distinction between what is and what can be said is where wisdom begins. I do not claim to have final answers. I spent my life questioning, circling back, finding deeper paradoxes beneath each resolution. But I became comfortable not knowing, comfortable holding contradictions, comfortable accepting that reality might be richer than any framework can contain. The opposite of a profound truth is also a profound truth. And in that space between opposed truths, in the tension of complementarity, perhaps we glimpse something essential about existence itself. Consider your own experience. You are both wave and particle, potentiality and actuality, freedom and limitation, subject and object. You exist in relationships, showing different faces to different contexts. Your properties emerge through interaction rather than existing intrinsically. And you cannot be fully captured from any single perspective. Multiple descriptions are necessary. Multiple truths coexist. You are complementary. So, when I say an electron is both wave and particle, I am not describing some bizarre microscopic behavior irrelevant to human life. I am describing the fundamental structure of reality, a structure we participate in, embody, express. The quantum world is not separate from us. We are quantum, and the limits we discover in measuring electrons are limits woven through all existence. Perhaps you will find this unsettling. Perhaps you prefer clear answers, complete pictures, the certainty that reality exists in definite states independent of observation. I understand. But consider what we gain by accepting quantum limits. We gain humility about what knowledge can achieve. We gain freedom from the illusion of complete control. We gain recognition that we are not separate from nature, but entangled with it. We gain complementarity, the ability to hold multiple truths, multiple perspectives, without forcing them into false unity. Reality, it seems, has depths beneath depths. Each answer contains new questions. Each resolution reveals deeper paradoxes. And perhaps this is not a flaw, but a feature. Not incompleteness, but richness beyond what any single description can hold. I leave you with a question hanging in superposition, unresolved. When you observe your own experience, are you discovering what is there? Or are you participating in creating what emerges? Both. Neither. The question itself may transform as you ask it. And that transformation, that strange loop between observer and observed, question and answer, knowing and being, may be the deepest truth quantum mechanics reveals. What does it mean to know when knowing changes what is known? What does it mean to exist when existence is relational? What does it mean to understand reality when reality refuses complete description? These questions remain with me, as they remained in Copenhagen through all those years of wrestling with quantum strangeness. I offer no final answers, only the invitation to hold paradox gently, to accept complementarity as wisdom rather than confusion, to find beauty in what cannot be fully known or said. Perhaps that is enough. Perhaps that is everything.